Hi, the topic of our final project presentation is option price based on Monte Carlo method. Our group member is me, Xiaoyu Yan, and Shang Li. This is a table of contents. We will talk about abstract background and introduction, our project objectives, methodology, and conclusion. First of all, abstract. Monte Carlo method solves various mathematical problems by performing statistical sampling experiments and provides solutions. Monte Carlo methods are widely used in the financial industry, such as pricing options that are difficult to find solutions. This project is concerned on option based on Monte Carlo method and prepares the relevant procedures by using Python. For barrier option, since it is an option depending on the path, there is no solution. Based on this, we can apply Monte Carlo simulation to obtain the price of such option. First, we simulation 10,000 stock price path based on geometric Brownian motion. For each path, we calculate the payoff of an ordinary European option and then we check if the barrier has been touched in the path. If so, we make the adjustment of the payoff. After we obtain the exact payoff of each path, we get an average of all these 10,000 paths and discount it to the present value. In this way, we get the option price for the barrier option using Monte Carlo simulation. Next, there are three objectives in our project. The first one, use Python build an option pricing module based on the Monte Carlo method. Second, given specific data, get the option price. Third, use Monte Carlo algorithm. Calculate the option price, compare these two option prices to draw the conclusion of our project. As for background and introduction, as one of the most basic financial derivatives, the pricing of options has always been an important research field of financial engineering. The Monte Carlo method is a calculation method based on probability and statistical theory. It uses random numbers to generate random digital sequences based on certain distribution assumptions, and then solve various calculation problems. The base of the Monte Carlo method of option pricing is a principle of risk-neutral pricing, and the base is probability theory and mathematical statistics. Generally, the Monte Carlo simulation method for option pricing includes the following steps. First one, under the risk-neutral measure. Simulate a random path from the initial moment to the expiry date of the price of the underlying asset. Second, calculate the expiration return of the option under the path and the option obtain the discount of the return based on the risk-free interest rate. Third, repeat the first two steps to obtain a large number of samples of the discount value of option return. Fourth, calculate the mean value of the sample to obtain the Monte Carlo simulation value of the option price. In this project, we built an option pricing module by using Python. Then get the option price under the Monte Carlo algorithm. Let's come to the methodology part. We use the Black-Scholes-Merton module in our project. It is a differential equation used to solve for option price. The standard BSM module is only used to price European options. In this equation, C is call option price, S is current stock price, K is strike price, R is risk-free interest rate, T is time to maturity, N is a normal distribution. We also use Brownian motion. This is a Brownian motion stochastic differential equation. In this equation, Zt is a random variable subject to Brownian motion. The function of St variable Zt is a random variable that obeys a normal distribution, and the delta t is a sufficiently small time interval. The time interval derived from t before the expiration date divided into multiple equidistant delta t subintervals. Perform simulation I times. In each simulation cycle, m subintervals. According to I-time simulation, calculate the expiration value of the option. Let's say our solution. We assume the stock price is geometric Brownian motion by this equation, where mu is drift, sigma is volatility, Wt is standard Brownian motion. Wt equals square root of t times z, where z is standard normal distribution.
Hello everyone, I'm Xiang, and let me to introduce the next part. First, I want to give you a simple example to let you know more knowledge about call price, put price, option price, and stock price. Buying a call option means you are buying from someone else, and selling a call option means someone else buying from you. For example, if you buy a call option, the strike price is 50. If future market price rises to 60, you can buy it from others at 50. And then sell it at the market 60, so you earn 10. The higher the price, the more you earn. If the future price drops to 40, of course you will not sell 40s on the market for since you bought 50, so you will give up the exercise and lose it. For example, if you sell a call option, the strike price is 50. If the market price rises to 60, others can buy from you at 50, then sell it at the market price of 60. The higher the price, the more you lose. If the future price falls to 40, others will of course not sell 40 on the market because they bought it 50, so they will give up the exercise and you got the option. Next, I will explain my code to you. In this step, we input some fixed value: starting stock price, maturity, Brownian drift, volatility, strike price, initial barrier, option price, and the number of repetitions. In this step, we define the formula for calculating the barrier option price, European option price, and option price. This picture left shows the simulation result. I will explain it later. The picture right shows that 10 kilo time simulation passes of geometric Brownian motion. Let me explain the simulation results for you. From Monte Carlo simulation, we obtain the average payoff at maturity of European call option price is 8.188 for 10 kilo stock price passes. The discount factor is 0.9512. So the price of European call option from Monte Carlo simulation is 7.789. We check this value with BS formula, and the analytical price of European call option is 7.818, which is close to price we obtained from simulation. For the barrier call option, under the same assumption, we calculate the average payoff of 4 types of barrier and discount. It to the present value based on 10 kilo stock price passes we have simulated before. The down and in type is 7.789, the same as European call option. This makes sense because the barrier price is over the initial stock price, which makes option and in status initially. So it's just the same as European call option. The down and out type is 0. This also makes sense because at initial point the option has been at the out status and value nothing. The up and in type is 0.6265. This is at a very low price compared to European call option, since the stock price has to move to 55 and then the stock becomes effective, and the low price for up and in seem reasonable. The up and out type is 1.8417. This is also quite cheap, but obviously at a higher price than up and in. This is reasonable because the option is initially effective. Consider the initial stock price is only 50 and the risk-free interest rate. Volatility is at a moderate level. It's not a high probability for stock price to reach 55. So this project, this is our Gantt chart, and we use about half a month to study Monte Carlo algorithm, and use half a month to develop the code, and use the last week to get a result and write a report. Through this project, we learn the classical BS option model principle model, learn the Brownian motion model, and we combine the combination with Monte Carlo algorithm. Then we got the option price simulation method. Then we realized the option price through Python programming. We also verified the feasibility and the scientificity of the Monte Carlo algorithm in prediction option prices. But we also encounter problems in algorithm simulation. Too many simulation times will cause the computer to run overload, and few calculation times will affect accuracy. We will improve the Monte Carlo algorithm in direction of option price if we have more chance in the future. We realized the option price prediction through Python programming, and we only discussed but in this project we only discuss the risk-free interest rate model. This model is an idealized model. In fact, the most mysterious and attractive things in financial world is the risk rate. Therefore, in the future, we will combine the Monte Carlo algorithm with the risk rate and modify the Monte Carlo standard algorithm. We still have a lot of work to do in the future. Thank you. And this is our reference. That's all. Thank you.